Here we are in part 2, where we're going to talk about this new space called tangent space. The tangent space is the space that we put textures in. It might also be called texture space sometimes. Now, if you think about it, think back to how we applied a texture as a UV map onto a mesh. We took a triangle and then we sort of place that triangle directly on the texture, like it might be picking up ink from a stamp or something like that. And that's how we applied it. So when we go down the U direction of the UV coordinates, we are going along the surface of the mesh. And we go in the V direction, that's going the other direction along the surface of the mesh. It's parallel to the geometric triangle. So what space is that? It's not model space or object space. Object space has the x-axis going down the model's x-axis. But as we go around the different faces of a model, the texture space bends around in different directions to constantly stay stuck to the surface. So thinking about the cube has 6 faces. On the front face, the U direction is parallel to the x-axis, and the V direction is parallel to the y axis of model space. But then when you go to the top surface of the cube, the U is still parallel to the x, but now the V is perpendicular to the y of model space. So this tangent space or texture space is the space that stays stuck to the surface of the mesh on whatever triangle you're talking about. Here we have the triangle out in model space, and this is the normal. The normal points outward away from the triangle. We had that before, and this is just the normal of the geometry normal, not the pixel normal. This is the normal of the geometry. And we will define along the U direction of the UV coordinates of this triangle, we'll put out a direction and call that the tangent. The normal points away from the surface. The tangent is parallel to the triangle. It's tangent to the triangle. And we'll call that the tangent. Now that gives us 2 directions. In the V direction of the triangle, so the V direction of the triangle up this way, also tangent to the surface, we'll create a 3rd axis, and we will call that either the bitangent, or sometimes you'll hear the binormal. Together, these 3 axes will define the orientation of a new space we are calling tangent space. So here's another example. Looking at this again, because this is a bit of an odd thing to think about. Imagine you have a triangle, and here are its UV coordinates. Now, this triangle is in some other space. Maybe it's in model space. It's in object space here. So this is sort of a diagonal triangle somewhere in model space. Its UV coordinates go like so. So that is what we will call the tangent direction, and that is what we will call the bitangent. All right, now this is what we're going to need to make normals work. Now the reason for that is we took a normal map and put it on as a texture. So it's in UV space. At the end of video 1, I asked the question, what space are these normals in? Well, now we understand they are in texture space or tangent space. If we want to use them for lighting, we'll need to transform out of tangent space into world space. In order to do this transformation, we're going to need a little bit more information about our geometry. We don't actually know which way tangent space points on any given triangle. So we're going to have to add that information. We already had, in our previous examples, we had a position for every vertex. That's pretty much a requirement. We're going to need a UV coordinate. That's how we'll know which part of the texture to get the normal map out of. We already had a normal for each vertex, and we're still going to need that here. But now we need these two additional vectors, the tangent vector and the binormal vector. I'm going to go back and forth between calling that a bitangent and a binormal. You'll hear both terms. So I need these three axes to tell me what the orientation of any vertex of my model is. And if I take three of those, that'll tell me the orientation of the triangle that they make up together, right? But these are going to create an axis. The normal, the binormal, and the tangent are going to create an axis, and that means they're all mutually perpendicular. And that means, given any two of them, I can just do a cross product to get the third. So very, very commonly, you won't actually store in your model all three. We're going to take one of them and just throw that out. So we're not going to waste memory storing the binormals of every vertex in our mesh. We're just going to store the tangent and the normal in our mesh. We'll do a cross product to get the binormal. Okay? So this is the structure that's going to go into the vertex shader. This is raw data that our mesh will need in order to pull off normal mapping. How about our vertex output? Well, we're going to have position and world position that we needed for lighting before. Of course, we still have our UV coordinates that I mentioned we're going to need. And like we had before, we'll want our world space normal. We're going to take that model space normal we got in the vertex shader, transform that into world space, and that'll go onto the pixel shader. We also got our tangent, which was in model space, and we transformed that also to world space. And like before, we don't actually need to output the binormal here. We're going to be doing some calculations in the pixel shader anyway, so let's go ahead and just do that cross product there. Okay, it's worth re-mentioning because this is a little bit confusing and the words get stumbled over each other pretty easily. This normal and this tangent were passed to us in model space. Now, we're talking about so many spaces. This can be confusing. That is, the tangent is the direction that represents which way the U coordinates go of the UV texture coordinates. And that would be a three-dimensional direction that points which way is parallel to the surface of my model at this point in the model. Just like our normal points which way is out away from the surface of the model, what is perpendicular to the model at this point, right? Thinking about a sphere, the normals of the sphere point outward everywhere away. They make like a porcupine on the sphere. The tangents of a sphere will all point parallel to the surface of the sphere, but in every which different direction as it goes around to different parts of the sphere. So we're going to use this to create what we were calling that tangent space.